Okay, we're going to do recursion. So I'm starting off with, it's a little more complex than it needs to be at the moment. It'll make sense when we do the recursive stuff. I'm just calling this function sum with a value of 3 and printing out the result. What that's supposed to do is, in this case, 0 plus 1 plus 2 plus 3 equals 6. Okay? So if we gave it 4, it would be plus 4 equals 10. So we're just taking the digits and adding them up to the maximum that we passed in. So the sum function is ultimately right now, or method, is just a for loop right now. This enter and leave thing is going to be useful when we do recursion because we're going to see what happens with recursion, which I'll describe shortly. So right now we have the result is assigned 0. Should be less than or equal to value. So we take 0 plus 1 plus 2 plus 3 and we return it. And it looks like this. 6, right? So we summed 3 and it returns 6. So it's just showing us that we called it with that and we're leaving, we're returning that. So recursion is having where you have a function or method call itself instead. So I'm going to copy this. We'll make a second one. We'll call it recursive sum. And we'll call it. So the idea is that we want to call our own method. So let's do the absolute worst possible thing we could possibly do, which would be to call recursive sum, passing in value. So we come into recursive sum, it does some stuff, it calls itself. We come into recursive sum, it does some stuff, it calls itself. And it keeps doing that forever. And we can see that it's calling sum 3 over and over and over again. You can also see I have a bug in my code. This should be, sorry, just 1 second. I'll explain what this does when we get to that part. Don't worry about it right now. Once we fix this mistake, I'll explain it. So this should make it shouldn't do this. Interesting. I think I might have to do call it toString explicitly. Or it could just be that it scrolled off the top of the screen. So okay, let me fix the mistake and then we'll figure this out. Basically, what that code is trying to do is increase the indent so that there's a couple of spaces every time we call it. So we don't want to recurse forever. That would be horrible. Okay. So what we need to do when we recurse is we need to basically, and this isn't always the case of how you do it, but for this it is. We're going to subtract 1 from it, for example. So we want to change it. That's also not going to fix it, but we might be able to see some stuff. If I scroll all the way over. So we see it getting smaller and smaller, right? It's getting smaller each time we call it. So the problem is that we've gone below 0. So this is what we call the base case. So if value is less than or equal to 0, we want to return 0. And not recurse anymore. So what we're saying is we're going to come in here with a value of 3 to begin with, and 3 is not less than or equal to 0, so we don't return. We come in here, we do the recursive thing. The recursive thing calls 3 minus 2 is, or 3 minus 1 is 2. So we come in here, it's 2. 2 is not less than or equal to 0. So we call it with 2 minus 1 is 1. 1 is not less than or equal to 0. So we come in here, we call it with 1 minus 1 is 0. So we come in here and it is equal to 0, and now we return. And that's going to unwind it. Now we'll see what happens. First we'll run it, and then we'll work out exactly what's happening. Okay, so we see we're getting called with 3, 2, 1, and 0, and then we're leaving on the way out. The problem is I also didn't print out that we were leaving. So we see a nice orderly, we came in with 3, we came in with 2, we came in with 1, we came in with 0, and then we're leaving. And we're unwinding the whole thing. So the problem is everything's always 0. That's just because we forgot to do one thing. The result is the recursive sum. That may or may not work. Let's see what happens. I think that'll work. Nope, still 0. Just trying to reorder my code here. Make it a little nicer. So let's work our way backwards to the base case. So we're going to return 0 here. And when we do that, normally I'd have a piece of paper that I could draw stuff. So let me try and simulate that piece of paper down here. So when value equals 3, we want to set our result equal to 3. And then we want to call with value equal to 2, right? That's when we call the value equal to 2, that's the recursive part here, right? So every time I indent, we're recursing. So now we want to return the result sorry. I'm going to recurse in, so forget the results right now. We're going to do value equal to 1, value equal to 0. Right, we've seen that. So what we want to do is take, at this level, we want to take the 0 plus 1 and return that. And then we're going to take the 1 plus 2. Right? 0 plus 1 equals 1. So that's that 1 here, plus 2 equals 3. And then we're going to take that 3 plus 3 equals 6. So this can be basically the return value plus the current value. And that'll be the same thing here. The return value plus the current value, the return value plus the current value. So that's the part we're missing here, is saying that the return value, this is the return value. So the result is assigned the returned value plus the current value. And current value is just whatever was past 10. Remember, this started off as 3, then it became 2, then 1, then 0. So if we run this, we now get 6, because we return 0, then we returned 1. 1 plus 2, right? 0 plus 1 is 1. 1 plus 2 is 3. 3 plus 3 is 6. 0 plus 1 is 1. 1 plus 2 is 3. 3 plus 3 is 6. So sorry, so that is the essence of recursion, is that we are going to call our own method up until we reach what's called the base case. So I'm going to do one more example, and then I'm going to get you to do something. Actually, I'm going to do a partial example and pause. Then I'm going to show you the solution. And then I'm going to get you to do another one. So I'm going to count down like a rocket ship, right? We're going 10, 9, 8. So count down. And this time we're not actually going to do anything with that. It's going to print out inside of it. So that's okay. We're going to do count down from 10. Okay, so I'm going to start with my base case. If value is less than 0, we're going to return. This can be void this time. Sorry, I'm going to also do my enter, and we're entering count down and the value, and we're also going to be just throw a 0 there because we're not actually doing anything. So from that point of view, I should change this to an object. Don't need the toString because that gets called automatically. The reason why that was disappearing before was it only the window only buffers so much, and you saw that it was starting at like negative 16,000. So the first 16,000 were just not showing up on the screen anymore. I'm trying to remember. Need to check something. I don't remember what the format specifier. I think I just have to do %s and it will convert it to toString. Sorry, I should have done this earlier. We get to see some stuff. So this objects.require null or else. This should print out result if it's not null, and if it is null, it should print out the word null. So I want to do the same thing for this one. So this, oh, too much. This will make it so that I can do any any parameter type. It doesn't have to be int now, right? So you first started off as ints, but now obviously we're not printing out ints, we're printing out, in this case we're returning void, so there's no, there's nothing, so we'll just have it print out as null. And then we need to recurse, so we'll call count down value -1. And let's see what happens. This should tell us that we're going 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, right? Because we call it with 10. It's not, 10 isn't less than 0, so we're going to come in here and do 9. So we call it with 9, right? All the way down to 0. When we call it with 0, it'll come in here and say, oh, that's fine. And then it'll become -1. Come in here, print out that we're calling it with -1, and then -1 is less than 0, so we're going to leave. And this should be leaving countdown. And we'll also want to do that, just so it prints out nicely. So this should print out 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0 sort of thing. We started at 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Got to -1, and then we worked our way out. Right? And that's exactly what recursion looks like. You saw a problem earlier where we essentially didn't have this. And when we ran it, this is with no base case, but this can also happen with a base case. You'll notice we got this exception. So this exception is a Stack Overflow error. So whenever you declare a variable, whenever you call a method, and whenever you declare variables, there's this part of memory that every program has called the stack. And it's a fixed size of memory, so you can use it up. Every time you call a method, it's got to push the parameters onto the stack. Every time you declare a variable, it's got to push that onto the stack. So every time you're calling a method, you're using up some memory. If you call too many methods without returning, which is what we're doing with that unbounded recursion is what it's called, then you will blow up the stack. You'll try and go past the end of the stack, and then you'll get a Stack Overflow exception. So we want to make sure we have this base case so we know when to stop. If we don't stop, it could be quite dangerous. Also, it's not a good idea to say equal to -1, because what happens if we have a bug in our program and we actually go from 0 to -2 without going to -1? So always do less than or greater than, less than or equal to, greater than or equal to. And you don't have to do it just with ints. You could do it with strings. So you could recurse until the string was equal to hello, right? For example. I don't know a case where you'd actually wind up doing something like that, but you could. There's no requirement that it be an int. You could have this method take 20 parameters. That's fine too. You're not limited to just one. But one of them is going to be the thing that sets up this base case. So I want to print out the values 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. I don't want to print out the -1. So I'm going to put this in here, system.println, value plus. It's excited, it's launching a rocket. So let's see what happens now. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and we also printed out -1. That should be less than 0. Now that I've traced through it, I'm just going to remove these comments because those enter and leaves are just there for debugging purposes. And when we hit 0, I'm going to do one more thing. Blast off. There we go. We've got our rocket count. Cool. So I forgot to pause the video to get you to try and do something, but that's okay. The other one is now I want you to change the code to count up from 0 to 10. Okay, so I'll do the solution here so we can see it. But pause the video now. You take your best stab at making it do it so that you can count from, so that the count goes, the count goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can get rid of the blast off, keep the blast off, doesn't matter. Okay, so pause the video and try and figure that out. Okay, here's the solution. That's it. One line. Just move it. Right? So if you put something before the recursive thing, it does it with the value. And then it recurses to the smaller value. If you do it after, it does a recursion to the smaller value, and then it does the value. Depending on what you're doing, both ways are valid. What I'm going to show you in class tonight is another example, but what we're going to do is we're going to recurse through directories. So we're going to see doing files, and you're printing out the files inside of a directory tree, which is a very natural use of recursion. That kind of thing lends itself very well to recursion. There's a kind of algorithm, we don't do it in this course, but there's these algorithms called graph algorithms. They also lend themselves nicely to recursion. In fact, pretty much anything you can do with a for loop, you can do with recursion. However, you shouldn't, okay? Recursion makes the code really simple. You will see it with the code tonight, where if you tried to do the file walking stuff without recursion, it would be an absolute nightmare. And I'm not even 100% sure I can do it reasonably. But recursion makes it a breeze. But things like this counting down, counting up, because every time you call a method, you make use of the stack, and because you could pass in a really large number, like integer max value, and then we were to run it, it'll crash, right? Because we've done too many. So we try and figure out what that size is. We try passing in 10,000, see if that works. That worked. We'll try 100,000. No, 100,000 doesn't work. Right? So we'll try 50,000. 50,000 doesn't work. Try 25,000. Doesn't work. Try what's half of 25. Okay, so maybe we'll try 20,000. 18,000. Also, this is horrible. You should never do this, what I'm trying to do. Also, there's an easy way I could tell you what the actual answer is. So all we have to do is go up and see what the last value printed was. But because we're doing it that way, it doesn't print until after it crashes. So. Nope. No, because I didn't print out anything. No, sorry, I'm looking at the wrong thing. Because I didn't print out the, just moved the wrong thing. Actually, that didn't help me. So what did we get to? We got to 17 works, 18 doesn't. 17.5 doesn't. So why this is horrible, aside from just wasting all our time, is that the stack size is totally dependent on the virtual machine. We can configure it, so you shouldn't rely on what the size is. Make sure I'm not losing my mind. Oh, okay, so 17 didn't work. Shouldn't rely on what the size is for this particular VM, because a different VM could be totally different. Even this VM could be configured to be totally different. Have I done something horribly wrong? So between 4,000 and 6,000. There is a reason why I'm doing this. You'll see it in the lecture. So it crashes between 6,000 and 5,000. So we'll do try 5,500. 5,000 and 5,500. We'll do 5,250. I'll try. Okay, so 5,054 is the largest number we can give it. However, you want to watch it break. And this should break. Oh, it didn't break. That's weird. I guess the way the stack is being used is different than I anticipated. I expected, and it could be optimizing it out because it knows it's always 0. Maybe this will do it. Maybe not. Yeah, okay. So it was an optimization. The virtual machine was being smart. Because now, every every time we call countdown, it's passing 2 parameters, which means it's using double a stack. So we should be able to do 2627. In theory, should work, or thereabouts. But if we do 2628, it shouldn't work, I would think. Yeah, all right. I've never, this is the first time in my life that I've cared this much about the stack, just to see what would happen. My point being, don't do this. It's horrible to try and work out what it is. I expected it to be half the value because we're pushing 2 things on the stack. Therefore, we're using up double the amount of stack. Therefore, it should crash at half the size. The point is, don't use recursion. That would actually be the point. Don't use recursion unless it makes things significantly better and there's not an alternative. Unless you can have it bound. So bound means that we know it's not going to blow the stack up. Bound means that we're probably not going more than a handful of levels deep. It is expensive to do recursion because of the overhead of making the call and passing the parameters. The for loop is far better because it doesn't have the overhead of calling another method. The overhead isn't great, but it does add up. The risk of blowing up the stack is bad. That being said, something like a directory structure, they're not usually that deep, maybe 100 deep, and that's pushing it. You'd be hard pressed to find a directory structure that's 100 deep. So you're not going to go too far down, typically. And the code is so much simpler with recursion than without it. So I would use recursion for that, definitely. I wouldn't use the recursion for the count up, count down, summing, a power function. It's not a good use of it because you can pass in such large numbers and cause cause it to blow up. So that's the basics of recursion, and I'll see you.